All right, class, to conclude our lesson on the chemistry of life or the chemistry of living organisms, we are going to cover macromolecules. Okay, here's a quick recap. Remember, the universe is made up of either matter or energy or a combination. And if it's matter, it has to be made up of atoms. You learn that there are different kinds of atoms known as your elements, like your hydrogen, carbon, and oxygen elements. And they differ by the amount of subatomic particles they possess. Your protons, which are positively charged, your electrons, which are negatively charged, and your neutrons, which have no charge, okay? So, since they differ in their amount of charges, all right, charges also provide a molecule with their properties. So since their charges are different, these elements, these different molecules also have different properties. For example, hydrogen. At room temperature, it exists as a gas. It is highly flammable. All right, it exists in the upper atmosphere because it's very, very buoyant. All right, it's very, it has a low density. Okay, carbon. Okay, because of its unique charges, can form 4 bonds. All right, and this is what led to carbon becoming the backbone of life. All right, oxygen. At room temperature, it also exists as a gas. Okay, now here's what you may not have known about oxygen. Oxygen is also very flammable. All right, it's not as buoyant as hydrogen, all right, but it does exist as a gas. Okay, now remember, all right, atoms may bond. All right, your different elemental atoms may bond to form molecules. Okay, once they bond, once a chemical change has occurred, the new unit behaves as one. Okay, so therefore, these 3 atoms right here will behave as one molecule. Okay, so if I combine oxygen with 2 hydrogen atoms, this new unit now possesses the charges of 3 atoms. Okay, 1 oxygen and 2 hydrogen. So since the charges have changed, so do the properties of this molecule. Okay, remember, these 2 highly flammable. All right, this highly flammable. Now this is H2O water. Is water highly flammable? In fact, water may be used to stop fires in some cases. All right, so hopefully that's a good example to think about when you're trying to understand the changes in charges relate to the changes in properties. Okay, atoms bond to form molecules. All right, different elements will bond to form molecules, and for this to occur, a chemical change has to occur. Therefore, a chemical bond will be formed or broken in a chemical change. Okay? Okay, next, molecules may mix to form mixtures. Okay? Now, once they mix, physical bonds, all right, may have formed. If the object is stuck together, physical bonds have formed. Okay? And these are your 4 different types of matter. Remember, there are 4 types of matter. You've got your elements or your atoms, that's 1. Okay? They may chemically bond to form your molecules. Okay, that's 2. All right? They may mix together, right? Molecules will mix together to form your different kinds of mixtures. You've got homogeneous mixtures that look the same, right? And then you've got heterogeneous mixtures that look different. And these are your 4 different types of matter. Now remember, these 4 can exist in up to 3 basic states, common basic states of matter, right? Your solid, liquid, and gas. Okay, example, H2O, ice melts into water, liquid, all right? You heat it up, evaporates into a water vapor gas, okay? Okay, now, because of its unique charges from one oxygen and two hydrogen atoms, water has very unique properties throughout the universe. And you guys have been looking at them through the water lab, all right? It's got what's called polarity. And what polarity means is that it's got an uneven distribution of charges, all right? However slight it is, if it's uneven, it's got polarity, okay? What that means is that one side is more positive and the other side is more negative, all right? Now, whenever something has polarity, it gains properties of attraction, okay? Kind of like a magnet, all right? Your magnet is attracted to other metals, okay? Okay, now, there are two attraction properties. One is called cohesion, okay? Cohesion is when something sticks to itself, okay? So when a water molecule sticks to another water molecule, cohesion, all right? More cohesion, okay? The slight negatives are attracted to the slight positives. Okay, now, adhesion, on the other hand, is when one molecule is attracted to another molecule. Okay, here's my water, H2O molecule. This is my nitrogen gas molecule. They may attract each other. Okay, so since it's different molecules, this is called adhesion. Kind of like how your tape adheres to your wall. All right. Okay, now it's because of adhesion and cohesion, the water can become what's known as your universal solvent. All right. Let's go over what this means first. Okay. There are a special kind of mixtures that has one part solid and one part liquid. All right. And these are called your solutions and suspensions. Okay. Special unique mixture with one part liquid state, one part solid state. Now, in this case, the solid part is known as your solute, all right? Example, in salt water, you've got a salt, and that's your solute, okay? Now, in a solution suspension, the liquid part is known as your solvent, okay? So, in salt water, the solvent will be the water, okay? The solute would be the salt. Okay, now the difference between the two is that a solution, all right, the solvent has dissolved the solute, okay? The liquid has dissolved the solid. Okay, and in this case, it's a homogeneous mixture. Okay, if I were to ask you what type of matter it is, homogeneous mixture. Okay, now in this case, again, you cannot see the difference between them. Okay, now the other type of mixture with liquid and solid is called your suspension. It's when the solvent has not dissolved the solid or the solute. Okay, and in this case, because you guys can see the difference, it's a heterogeneous mixture. Okay, now the difference between them is the amount of attraction between the solvent and the solute. Okay, water might be more attracted to certain things than other things. All right, just like how your magnet is attracted to your refrigerator, but it's not attracted to your drywall. You can't stick your magnet to your wall, can you? Okay, so similar to that, okay, water may be more attracted to certain molecules. Okay, so in this case, if it is really, really attracted to a certain molecule, like say salt, okay, then or oxygen, then it would dissolve it, okay, and in this case, it will form even bonds, physical bonds, with the solid solute. All right. Now, if if it doesn't dissolve, all right, that means that it cannot form even bonds with the solute or the solid. Okay. Therefore, the suspension, you will be able to see little pieces, all right, and it will separate over time. Okay, and that's the difference between a solution and a suspension. Okay, real quick, atoms combine to form molecules. Okay, like water, and then molecules combine to form large molecules or macromolecules. Okay, like this saturated fat molecule here. Okay, now we're gonna go over your macromolecules, and to define macromolecules, we'll use polymers and monomers. Okay, poly means many, so polymer is the whole pattern, like this whole chain, this whole link, all right, paperclip chain. Monomer will be one. Okay, so one paperclip in this paperclip chain. Okay, so monomer, polymer. Okay, now there are four macromolecules of life: lipids, carbohydrates, proteins, and nucleic acids. All right, and water was able to dissolve these things so that they could be introduced together. Okay, without water to dissolve these things, it's theorized that life would not have happened. Okay, it's because of how sticky water is toward carbohydrates, proteins, and nucleic acids that it could stick to it, mix it all up, and combine them. Okay, and this is theorized the theory of how life evolved with the help of water, because water could dissolve these things into a solution, eventually combine with lipids to evolve into your first forms of life. Okay, so we're going to go over these four individually. All right.